Right now, someone in your company is building an AI agent. They're using ChatGPT or Claude. They're uploading some files. They're calling it a solution, and they're wrong. The assumption killing most agent projects is this: agents are just chat interfaces, smarter chatbots, better search, flashier conversations. The reality is harder. An agent without the Microsoft Graph is disconnected from your business logic. It can talk, it can generate text, but it doesn't know what your organization actually does. It doesn't understand who reports to whom, where the data flows, or why you make decisions the way you do. In this episode, we're going beyond the hype. We're talking about why the graph isn't just an extra layer you bolt onto an AI system. It's the structural foundation. It's the difference between an AI that hallucinates and an AI that acts with authority. Who is this for? You. If you're an architect deciding if agents are a toy or a transformation tool, if you're responsible for systems that touch customer data, employee records, or critical workflows, if you're sitting in a room where someone says, let's build an agent, and you need to know if that's a 3-month project or a 3-year mistake, here are the stakes. 74% of enterprises are running agents right now, but only 21% have governance that actually works. That gap isn't closing, it's widening, and the organizations that close it first will move faster than everyone else. The context gap. Why LLMs alone fail in enterprise. Let's start with the foundation. What is an LLM? It's a pattern matching engine trained on public data. It sees patterns in text and predicts what comes next. That's extraordinary. But it's also completely disconnected from your organization. When you ask an LLM about your business, it knows nothing. It has never seen your org chart. It doesn't know which systems talk to each other. It has no idea what approved means in your company, or what happens when an agent tries to move $1 million without authorization. So what happens? The model guesses. And when it guesses about your business, you get hallucinations. Not harmless ones, expensive ones. A support agent tells a customer their order shipped when it didn't. A recruiting agent schedules interviews in the wrong time zone. An operations agent recommends a change that breaks your infrastructure. Enterprise agents need 3 things: context, memory, and the ability to act. Context means understanding what's actually happening in your organization right now. Not what training data says companies generally do, what you do, how meetings get scheduled, who can approve what data is sensitive, and what is public. The difference between knowing about something and understanding it is that understanding happens when the model reasons about your specific reality, not patterns it saw in a dataset. Memory means an agent doesn't start from zero every time you talk to it. It knows what happened last week. It understands the history of a transaction. It can track state across conversations. It can say, we tried that approach already and it didn't work. The ability to act means an agent isn't just a fancy search engine. It can schedule meetings, send emails, and create tasks. It can update records and make decisions and execute them with authority. An agent that can only read is not really an agent. It's just a retrieval system with attitude. Without those 3 things, context from your organization, memory of what happened, and authority to act, you don't have an agent. You have a chatbot that sounds smart and hallucinates expensive mistakes. The Microsoft Graph is where all 3 of these requirements come together. Graph as enterprise memory. Microsoft Graph is not an API. That is the first thing you have to understand. Technically, yes, it is an API. You can call it and send REST requests. But if you think of it as just another endpoint, you are missing the architecture entirely. Graph is the organizational nervous system. It is the system that knows how your company actually works. Inside Graph sits 20 years of communication patterns. These are not archived emails or old documents sitting in cold storage. These are living, queryable relationships. It knows who talks to whom. It sees how decisions propagate through the organization. It tracks what gets approved and what gets blocked. It knows which teams collaborate across boundaries and which ones never speak to each other. It identifies the individuals who hold institutional knowledge that nobody else has. This is not transactional data. Transactional data is just a record of what happened. A meeting was scheduled. A document was created. A task was assigned. Those are just events. They are snapshots. What Graph contains is behavioral intelligence. It sees the pattern of who initiates meetings with whom. It understands the structure of which teams rely on each other to get work done. It knows which communication channels actually move decisions forward and which ones are just noise. It understands that when finance and engineering both talk to product, something important is being decided. When you look at your SharePoint sites, your Teams channels, your Outlook calendars, and your OneDrive folders, you are looking at fragments, individual systems, separate tools. What you are actually looking at is a knowledge graph, a connected structure of entities and relationships. The problem is that the connections are invisible. They are distributed across multiple systems. An agent cannot see the structure unless Graph stitches it together. That is what Graph does. It unifies those fragments into a single queryable model. Your team's data does not live in a separate silo from your Outlook or SharePoint data. Graph sees them as one organism. It is one connected system that shows the actual flow of work and information through your company. This is how agents discover what your organization actually knows. An agent can ask who in the company understands how to onboard a customer in Europe. Without Graph, the model would guess based on titles or previous conversations. With Graph, the agent can trace actual patterns. It sees which people participate in European onboarding conversations. It identifies who sends emails about European compliance. It knows which teams' channels discuss European workflow. The agent is not searching for people who claim to know something. It is finding people whose behavior proves they know something. That distinction matters because the signal is not documents. Most organizations have mountains of documentation that nobody ever reads. Procedure manuals, playbooks, policy guides, they sit in SharePoint gathering dust. An agent that searches for documents finds noise. The signal that matters is behavior. How do people actually use systems? Which messages get read, which documents get shared and reshared, which workflows actually get executed. Behavioral intelligence tells an agent what is real versus what is theoretical. It shows what people actually do versus what the handbook says they should do. When Graph pulls in that behavioral layer, it transforms context. An agent no longer has to reason about your organization blindly. It has a map of how work actually flows. It knows which decisions matter. It understands the hidden dependencies. It sees which individuals are irreplaceable because their knowledge is woven into the fabric of how decisions get made. That context is the first piece, but context is only useful if an agent can do something with it. But discovery is only half the problem. Agents also need to act. Read access versus write access, the permission boundary. Here is where most agent deployments stall. Right now, the vast majority of agents in production are read-only. They can retrieve information. They can analyze what is in your systems. They can surface insights, but they cannot change anything. They cannot write, they cannot create, they cannot execute. This is not accidental, it is deliberate. Organizations default to read-only because it feels safer. If an agent can only look at data, the argument goes, what is the worst that can happen? It might give you a wrong answer, it might hallucinate, but it cannot break anything. That logic collapses the moment you understand what agents are actually for. Read-only agents are search engines wearing a trench coat. They are better search engines, they are faster, they can reason over your data in ways a keyword search cannot. But they are not agents, they are not automating work. They are surfacing information and asking humans to act on it, which means the bottleneck moves, but it does not disappear. You still need someone to read the agent's recommendation and then go manually execute it. The real value unlock happens when agents can write. When they can schedule meetings instead of recommending times, when they can send emails instead of drafting them, when they can create tasks instead of listing what needs to be done, when they can update records instead of flagging which records need updating. That is when you move from agent as assistant to agent as worker. But write access is where governance gets complicated because read access and write access are not on the same spectrum. They are different categories entirely. Read access is bounded. An agent reads what it has been given permission to read. If it reads something wrong, the error is in interpretation, not in system integrity. The data is unchanged. The organization's state is unchanged. Write access crosses a line. When an agent writes, it changes the state of the organization. It creates facts that other systems depend on. It makes decisions that affect other people's work. It commits the organization to actions that have downstream consequences. That is what write access means in a governance context. It is not just permission to modify a database field. It is authorization to act on behalf of the organization, to speak for the organization, to change what is true in the organization's systems of record. Most deployments fail at this boundary because they do not think about it clearly. The solution is a three-tier model. First, you have read-only, where agents can retrieve information but cannot modify it. Second, you have conditional write. This is where agents can make changes within defined bounds. They can schedule a meeting but only within business hours. They can create a task but only if it is below a cost threshold. They can send an email but only to internal recipients. Third, you have human-approved write. This is where the agent proposes an action, presents evidence to a human, and waits for authorization before executing. Why do most deployments fail between these tiers? Because the boundaries are fuzzy. An organization says agents can write without defining what that means. An agent gets broad permissions. It makes a decision that seemed reasonable in isolation, but breaks something downstream. A marketing agent schedules a customer call for a time when the sales team is in a meeting. An IT agent creates an account with too much privilege. An HR agent sends an offer before the background check completes. The failures are not failures of AI capability, they are failures of governance clarity, which is why every write must be logged and attributable. Not just something changed, but who authorized it, what the agent was asked to do, what evidence it considered, what it decided and why. If something goes wrong, you need to reconstruct the decision chain and understand where the governance boundary broke. That audit trail is the difference between authorized agent action and rogue automation. Tool calling, the bridge between agents and systems. Now let's get practical. How does an agent actually connect to Graph? How does it move from understanding context to executing actions? The answer is tool calling. This is the mechanism that sits between the model and the system. It's how the agent decides what to do. Here's what happens. You ask an agent to schedule a meeting. The model doesn't generate a calendar entry directly. Instead, it recognizes that the user's request requires a specific function to be invoked. It decides, I need to call the schedule meeting function. It determines what parameters that function needs, who should attend, what time, which room or Teams link. Then it packages that decision as a structured request. That's tool calling. The LLM deciding which function to invoke and with what arguments. Now, there's a difference between function calling and structured tool use, and that distinction matters architecturally. Function calling is what Azure OpenAI gives you. You define a set of functions with schemas, name, description, parameters. You send those schemas along with your prompt. The model reads the schemas and decides whether to call a function, which one, and with what arguments. It returns a structured response. You then execute the actual function outside the model. The result comes back to the model, which reasons over it and generates a response. This is the baseline. Azure OpenAI function calling works. It's production ready. Major agent frameworks build on top of it. But raw function calling has a limitation. It's stateless. Each call is isolated. The model makes a decision. You execute it. The model sees the result. It makes another decision. Each step is a separate interaction with the model. Structured tool use goes deeper. Instead of scattered function calls, you organize them into a workflow. You define nodes, decision points where the model reasons about what to do next. You define edges, transitions between nodes based on what the model decided. You chain these together into a directed graph, where each node is either an LLM call making a decision or a tool node executing an action. LangGraph is the production framework for this. It treats a workflow as a graph of nodes and transitions. A planner node decides what steps are needed. A tool node executes one of those steps. A verification node checks whether the execution succeeded. A human approval node waits for authorization before committing. The graph knows which node to go to next based on what the previous node produced. Why does this matter? Because real enterprise workflows are not linear. An agent doesn't schedule a meeting by calling one function. It reads someone's calendar. It checks for conflicts. It finds available times. It gets confirmation from the attendees. It sends the invite. It documents the meeting in a shared system. Each step depends on the result of the previous step. If something fails, the agent needs to backtrack and try a different approach. A single function call cannot express this complexity. A graph can. The latency cost is real, though. Each tool call adds a network hop. Read an email, one hop. Check a calendar, another hop. Validate availability, another. The delays compound. An agent that needs to schedule a complex meeting with 7 attendees across 3 time zones might make 30 tool calls, 30 hops. Even at 50 milliseconds per hop, that's a second and a half before the user sees a result. This is why schema design matters more than model capability. If you design your schemas poorly, if each schema requires multiple tool calls to do what one well-designed schema could do, you'll hit latency walls that no model capability can overcome. A good schema lets the model accomplish more with fewer calls. It exposes the right level of abstraction. It bundles related operations together. Here's a concrete example. An agent needs to schedule a meeting. Bad approach. Call get available times. Call send meeting invite. Call update calendar. 3 functions, 3 hops. Better approach. One schedule as meeting function that takes attendees, time, title, and optional parameters. It handles availability checking internally. The model makes one call, one hop, same result. This is the bridge between context and action. Tool calling is how agents move from understanding what needs to happen to actually making it happen. Graph provides the context. Tool calling provides the execution mechanism. Together, they transform an agent from an information system into a decision-making automation. But there's still a gap. Tool calling is manual. An engineer has to define each function, has to write the schemas, has to maintain them as systems change. The bridges are fragile because they're hand-built. There's a better way. Tool calling works, but it's manual and fragile. There's a better way. Model context protocol, the standardization layer. The problem with hand-building tool calling is that it doesn't scale. You have one agent framework. Another team uses a different one. One model supports OpenAI function calling. Another uses Claude's tool use. One integration uses REST. Another uses gRPC. Every connection is custom. Every schema is bespoke. Every organization is rewiring the same bridges over and over. This is the NXM problem. You have N different models and frameworks trying to talk to M different systems. That's N times M integration points. Every time you add a new model or a new system, the complexity multiplies. The fragmentation becomes unmaintainable. Model context protocol solves this by collapsing the complexity into N plus M. One protocol, multiple implementations on both sides. A model doesn't need to know how many systems exist. A system doesn't need to know how many models want to use it. They talk through MCP. What is MCP exactly? It's a wire protocol for agent-to-tool communication. It's JSON RPC 2.0 sitting on top of HTTP or STDIO. It standardizes how models discover tools, what information they need to call them, and how results come back. A model sends a structured request. The MCP server receives it. The server routes it to the right tool. The tool executes. The result flows back through the protocol. The model sees a standard response format regardless of whether the backend is a database, an API, or a custom service. Why does this matter? Because in 2025, MCP adoption grew 340%. It's not a niche protocol anymore. Claude supports it. ChatGPT supports it. Grok supports it. Google is building it in. Microsoft is building it in. This is not a future scenario. This is what's happening in production right now. The adoption happened because MCP solved a real problem. Organizations were drowning in bespoke integrations. Every agent needed custom schemas. Every system needed custom wrappers. MCP flips that model. You define the tool once. You expose it through MCP. Any model that understands MCP can use it. You don't redefine it for Claude and again for GPT and again for your internal models. Once. Through the protocol. The performance differences matter architecturally. Standard MCP, the JSON RPC variant over HTTP, delivers about 50 to 100 milliseconds per tool call. That's 1,000 requests per second throughput. It's reasonable for most workflows, but if you're building high-volume systems, if you're orchestrating dozens of agent tool calls per second, that latency becomes noticeable. This is where gRPC MCP enters the picture. Instead of JSON RPC over HTTP, it uses gRPC over protobuf. The performance jump is dramatic, 5 to 15 milliseconds per call, 5 to 10 times faster, and throughput scales to 10,000 requests per second. For an architect deciding whether agents can handle production load, this is the difference between a viable system and a bottleneck. The architect's choice when building systems that need speed and scale is gRPC MCP. Not because it's flashier, because it actually runs fast enough to power real business workflows. But performance is not the only reason MCP matters. It's also more secure and governance-friendly than hand-built integrations. Here's why. With custom tool calling, every system needs to know about every model that might call it. Every system needs to implement its own authentication, authorization, and logging. It's fragmented. It's error-prone. Security logic gets re-implemented badly across multiple systems. MCP centralizes this. The protocol itself can enforce standardized authentication. MCP servers can implement uniform permission checking. Every tool call flows through a single audit layer. The governance boundary becomes clear. The security model becomes uniform. An organization can say all tool calls must use MCP and then enforce that at the protocol level rather than hoping every team implements security correctly. Microsoft's MCP server for enterprise takes this further. It's not just a generic protocol anymore. It's graph data exposed through MCP. It's your organizational nervous system wired into every model that supports the protocol. An agent doesn't have to understand Graph's complex API surface. It understands MCP. MCP handles the translation. The agent gets what it needs. Graph stays clean. The boundary is clear. The standardization layer is where scale becomes possible. Not because MCP is magic, but because it takes the fragmentation out of agent-system communication. MCP is infrastructure. Now let's talk about what agents actually do with it. Graph connectors, bringing external data in. Your organizational nervous system is incomplete. The Microsoft Graph sits at the center of your environment, and it knows exactly what happens inside Microsoft 365. But in reality, most of the data that actually drives your decisions lives somewhere else. Your product roadmap is in Jira. Your customer contracts are in Salesforce. Your design assets are in Box. Your technical documentation is in Google Drive. And your vendor agreements. Those are scattered across a dozen different systems depending on which team negotiated them. Graph connectors are the ingestion layer for all that third-party content. They are designed to solve the knowledge silo problem. What is actually happening in production right now is that organizations are connecting Box, Google Drive, Jira, and Salesforce directly into Microsoft 365. They are not doing this by exporting data and re-importing it, and they are not forcing people to switch tools. Instead, they are making that external content queryable through the same system that already powers search, discovery, and agent reasoning. When a connector is active, an agent does not have to choose between searching internal knowledge or external systems. It searches both. Because the connector has indexed that external content, the agent sees it as part of the same organizational knowledge base. An HR agent recruiting for an engineering role can query job descriptions in your ATS, skill requirements in your internal wiki, and historical performance patterns of similar hires all in one search. It happens through the unified interface that Graph provides. But here's the problem. Most implementations stumble on the difference between indexing and understanding. A connector indexes content. It reads data from the external system. It extracts text. It makes the content searchable. That is valuable because it solves the "I can't find anything" problem. But indexing is not understanding. When a connector indexes a Salesforce opportunity record, it pulls the account name, deal size, stage, and close date. An agent can find records matching those keywords, but the agent does not understand the relationships. It does not know that this specific opportunity is tied to a customer with a history of delays, or that they are likely to renegotiate pricing and require executive approvals. Understanding requires more than indexing. It requires context. You have to connect that indexed data to other signals the agent already knows. This is why the governance model for connectors matters. It determines how much context the agent can actually access. When you enable a connector, you are making a governance choice. You are deciding what data agents can access from that external system, who can see it, and what they can do with it. These are not technical decisions, they are organizational decisions. A Salesforce connector that gives agents access to all opportunities might give them visibility into deals they should not see. A Jira connector that exposes every ticket might give agents access to security issues, customer complaints, or internal frustrations. The governance model is simple. Who can access connector data and under what conditions? This has to map back to your organization's data classification. If something is marked sensitive in Salesforce, the connector should respect that. If access is restricted in Jira, the connector should enforce it. Otherwise, you have solved the knowledge silo problem by creating a security problem. Most production pilots start through the 1 million item free trial. This lets you test a connector against real data at scale without committing to a full production setup. You can see how many items index, how search performs, and how the connector affects query latency. You can measure whether the governance model actually works. And then, you expand, connectors bring data in, but enterprise agents need to orchestrate across multiple systems. Graph Data Connect, the analytics pipeline. There is a flip side to this story. Connectors bring data into Microsoft 365. But MGDC, Microsoft Graph Data Connect, does the opposite. It moves data out. Specifically, it extracts Microsoft 365 data at scale into Azure for analytics and machine learning. This is where the architecture deepens. Agents do not just need real-time access to what is happening right now. They also need to understand patterns and trends. They need signals that only emerge when you step back and look at months or years of behavioral data. Graph Data Connect is your bulk export pipeline. You point it at your tenant and tell it which data you want. Email metadata, meeting patterns, file collaboration, or communication flows. It pulls that data out and lands it in Azure. You can put it in a data lake, Synapse, or Fabric, wherever you want to analyze it. The extraction happens in batches. It is not a constant stream. These are scheduled jobs that run on your timeline. The critical distinction is this. Real-time graph calls are transactional. An agent makes a request right now and gets an answer right now. It reads an email that arrived 5 minutes ago. It checks a calendar for tomorrow. It creates a task this instant. That answers the question, what is the current state? Batch analytics answers a different question. What patterns are hiding in the data? It is not just about what happened, but why it happened. It is not just about individual events, but how they connect. It is not just the present state, but the trajectory. This is where agents become predictive instead of reactive. An HR agent does not just react when someone submits a resignation. It analyzes years of communication patterns. It looks at how often people talk to their manager, how many times they have updated their LinkedIn profile, and whether they have been attending training sessions or skipping them. Individually, those signals mean nothing, but when you aggregate them across a year, they predict attrition. An agent with access to that behavioral intelligence can identify flight risks 6 months before they become departures. It can flag when someone is disengaging. It can recommend interventions before it is too late. This is what MGDC unlocks, not just data, but behavioral intelligence. There is a massive difference between knowing that someone sent fewer emails last month and understanding that this pattern, combined with their meeting attendance and project assignments, indicates they are preparing to leave. Production agents use MGDC output for 3 things. First is pattern detection, which finds deviations from normal behavior. Second is anomaly analysis, which helps you understand what caused that deviation. Third is forecasting, where you project future outcomes based on current trends. But here is where governance becomes complicated. MGDC moves sensitive data, workplace communication, meeting patterns, and social graphs from Microsoft's managed environment into your Azure subscription. You now own that data. You control who can access it. You are responsible for protecting it. Moving sensitive workplace data to Azure requires explicit organizational consent. This cannot just come from IT. It has to come from the people whose data is flowing through the pipeline. This is why MGDC deployments need transparent governance. You need clear data classification and explicit communication about what is being extracted and why. The deeper pattern here is that MGDC becomes the foundation for adaptive context layers. The idea is that agents should not just respond to immediate requests. They should understand the organization deeply enough to anticipate needs, predict problems, and recommend actions that would have been impossible with transactional data alone. Think about an agent that analyzes communication patterns to predict attrition. A manager has not explicitly said they are thinking of leaving. There are no resignation letters and no interviews visible on the calendar. But the communication graph tells a story. They are responding more slowly to emails. They are not joining cross-functional meetings anymore. They are not initiating projects. The pattern is clear. The agent surfaces this as a risk. The organization intervenes. A conversation happens. A promotion materializes, and the person stays. That intelligence, that ability to read the organization's behavioral health, lives in MGDC. It does not live in real-time graph calls. It lives in the analytics pipeline. Now we have data flowing in multiple directions. How do we orchestrate agents across this? The supervisor-agent pattern, orchestration at scale. Your architecture starts to get interesting here. Up until now, we've talked about context and tool calling as if one agent does all the work. But in reality, that's not how the enterprise operates. Real workflows are too complex for a single brain. They require different kinds of expertise happening in a specific order. Think about a standard HR hiring workflow. A single agent would have to master sourcing, screening, compliance, and scheduling. It would need to generate offers and run background checks. It would have to decide exactly when to move a candidate to the next stage. And then there are the edge cases. What happens if a background check fails? What if the interviewers are all out of the office? If you build one agent to do it all, you end up with a bloated monolith. It gets paralyzed by the complexity. It can't reason clearly because it's trying to hold too much at once. The solution is the supervisor-worker pattern. You have one orchestrating agent that coordinates a team of specialists. Each specialist owns a very narrow domain. The supervisor doesn't actually execute the work. It decides which worker should go next, validates what they produce, and determines the next step in the chain. We see this in production HR deployments right now. Lucy is the supervisor. When a job requisition comes in, she doesn't process it herself. Instead, she invokes Rex, the sourcing specialist. Rex searches the ATS and LinkedIn to find a ranked list of candidates. Lucy takes that list and checks it against the approval criteria. Then she calls Olivia, the compliance specialist. Olivia checks for diversity and policy adherence. If she finds an issue, she flags it. Lucy then decides whether to escalate that flag to a human reviewer. If everything looks good, Lucy calls Tim, the automation specialist. Tim handles the interview invites and tracks the responses. These agents never overlap. Rex doesn't care about compliance. Olivia doesn't touch the calendar. Tim doesn't look for resumes. Each one does one thing perfectly. Lucy is the one who knows the order and what success actually looks like. But here's the problem. People often confuse this with a swarm. A swarm is organic. It's autonomous agents negotiating with each other to find a solution. That is not what we're doing here. In this model, every handoff is explicit, every decision is logged, every escalation is auditable. The supervisor-worker pattern is a state machine. You can trace the exact path a requisition took through your system. You can point to the specific decision that led to the outcome. For governance, that transparency is everything. The state machine is how agents track their progress. The work starts in a received state. Lucy moves it to sourcing. Rex finishes his job and the state moves to compliance review. If a human has to step in, the state moves to escalated until they move it back to approved. This is where LangGraph becomes your production infrastructure. It isn't just a framework for tool calls, it's the engine for the state machine. Each agent is a node, each transition is an edge. Lucy's decisions are routed through nodes that determine which path to follow. The result is a graph you can visualize, reason about, and debug. And because this is production, you need checkpointing. An HR workflow might take an entire week. Rex finds candidates on Monday, Olivia reviews them on Thursday. A human looks at an escalation on Friday. If the system goes down on Wednesday, you don't want to start over. The system checkpoints. It remembers exactly where it was and what happened in the previous steps. The candidate list doesn't get resourced, the invitations don't get sent twice. That resilience is what separates a pilot project from a real production system. It's how you scale. This pattern works, but it only works if agents can actually trust each other. Multi-agent coordination, handoffs, and escalation. But here's where most multi-agent systems break. The supervisor model only works if the workers can hand off work without dropping the ball. We call this the handoff problem. If Lucy decides that Rex's candidates need to go to Olivia, how does that actually happen? Lucy doesn't send Olivia a message. She doesn't send an email saying, check these 3 people. In a high-volume system, that fails immediately. Messages get lost. Context gets stripped away. Olivia wouldn't know why those candidates were picked. She couldn't tell if the selection was biased or if the search was thorough enough. The naive approach is simple message passing. Agent A tells Agent B to do something. But that creates the same fragmentation we see with humans. Information gets translated, details get lost, assumptions get baked in. A sourcing agent might output a list ranked by match quality, but the compliance agent needs that list grouped by demographic diversity. The formats don't match, the expectations don't align. The architecture that actually works in production uses shared state. Instead of passing messages, there is one authoritative data structure that every agent reads from and writes to. Lucy doesn't hand off to Olivia. She updates the shared state to show the work is now in the compliance phase. She writes the candidate list and the reasoning behind it into that state. When Olivia steps in, she looks at that same source of truth. She sees exactly what Lucy saw. She performs her review and updates the state with her findings. When Tim takes his turn, he reads that same data. No translation is required, no context is lost. This is why checkpointing is so vital. The shared state is the checkpoint. Every agent can resume from it. Every change is atomic. Either the update happens completely or it doesn't happen at all. You never end up with partial data or inconsistencies. But even with shared state, agents have to validate each other. Lucy cannot blindly trust Rex. Olivia cannot assume Tim scheduled the interviews correctly. The validation pattern is straightforward. Before you accept an output, you run a check. Olivia runs a function to see if the candidates actually match the job requirements. She verifies the calendar isn't already booked before Tim sends the invites. If the validation fails, the work stops. An exception is raised, and Lucy sees it. She then decides if Rex should try again, or if it's time to call a human. The escalation trigger is that specific point where the agent hands off to a person. When does Lucy escalate? She does it when the decision is something an agent shouldn't make alone. If Olivia flags a compliance risk, that's an escalation. That affects legal exposure, not just the process. If sourcing returns 0 candidates after 3 tries, that's an escalation. Maybe the job requirements are just unrealistic. You define these thresholds upfront as part of your governance. If there's a resume gap over 2 years, you escalate. If a candidate comes from a direct competitor, you escalate. These aren't technical bugs. They are organizational rules that require human judgment. Measuring the success of these handoffs is the KPI that matters. How many tasks finished without a human? How often did we have to escalate? What was the time cost when we did? In mature systems, we see a 45% reduction in manual handoffs when agents use shared state. It's not because the agents are doing everything, it's because they are reducing the friction in the steps they do handle. They only escalate when it's truly necessary. They move the qualified work forward without needing a human to click approve at every single stage. Coordination works when agents have clear boundaries. Let's talk about those boundaries. Identity and least privilege. The security foundation. This is where the system either holds together or collapses under its own weight. Agents cannot share human credentials. This is not a preference, it's a requirement. And yet, in production deployments across 2026, organizations are still trying to run agents with shared accounts. A service account password that 5 agents know, an API key embedded in 3 different applications, a human's credentials delegated to automation because it seems simpler than setting up separate identities. But here's the problem. Every time this happens, governance fails. Not eventually, immediately. Because the moment you can't attribute an action to a specific agent, you've lost the ability to enforce accountability. If 3 agents share an account and something goes wrong, which agent did it? You have no answer. You have logs showing the account accessed a file, but you have no trace of which agent made the decision, and you have no way to restrict what that particular agent can do differently next time. The requirement is clear. Each agent gets a dedicated Entra workload identity, not a shared service account, not a human credential borrowed and delegated, a separate identity that exists only for that agent. That identity has its own password or certificate, its own permissions, and its own audit trail. When Lucy, the HR supervisor, makes a decision, the system logs that Lucy made it, not some shared account labeled automation. This is the foundation of least privilege for agents. Least privilege doesn't mean minimize what the agent can access. It means give the agent exactly what it needs to do its job, nothing more, nothing less. A sourcing agent needs to read from the ATS and LinkedIn, but it doesn't need to read HR files or access the finance system, and it definitely doesn't need to modify anyone's record or delete data. The permission model has 3 layers. First, graph scopes. What APIs can this agent call? Second, connector access. If this agent uses external data, which connectors can it query? Third, data classification. Some data is marked sensitive or confidential. Can this agent access it? An agent that sources candidates might have these permissions: read from the ATS connector, read from LinkedIn connector, and read public Teams channels where open roles are discussed. Not write to ATS, not read from Salesforce, not access personnel files. It's a narrow permission set, specific to its job, auditable down to the individual scope. The compliance specialist agent has different permissions. Read from the ATS connector to see the candidates, read from the HR data repository to check policies, and read from external compliance databases to verify regulations. It doesn't have write access to anything. It can flag issues, but a human or a supervisor agent makes the decision to act on them. And that's where things change. Because most deployments get it wrong. They over-permission agents to avoid having to manage complex permission hierarchies. They give an agent access to everything it might need, plus some things it probably doesn't. An agent that handles hiring gets full SharePoint access because it might need to read policies, and an agent that manages IT tasks gets permissions to every system because we might ask it to do different things later. Over-permissioning is the #1 cause of AI breaches, not because agents are malicious, but because overly broad permissions create attack surface. A compromised agent with full system access isn't just dangerous because of what it was designed to do, it's dangerous because of all the things a compromised agent could be tricked into doing. A prompt injection attack that makes an agent export confidential data becomes viable when the agent has export permissions it never needed. Conditional access for agents applies the same policy framework that protects human users, not just permissions but risk-based controls. If an agent is accessing resources from an unusual location, block it. If an agent is making a pattern of calls that looks like data exfiltration, flag it. If an agent is running at a time outside normal operating hours, require additional validation. These are the same controls that protect humans. Now they protect agents. A real example, an email triage agent. It can read emails from a specific mailbox. It can flag urgent ones. It cannot delete emails. It cannot forward them externally. It cannot access attachments. It cannot modify the inbox rules. Every constraint is explicit. Every permission maps to a specific job function. The agent is useful because it understands context and escalates appropriately. It's safe because it cannot cause damage even if its reasoning is wrong. Identity is the foundation. Now let's talk about what happens when things go wrong. Audit trails and observability. Making agents accountable. Here's what keeps compliance officers awake at night. We don't know what the agent did. You have an agent operating in your system. Something goes wrong. Customer data leaked. A financial record was modified incorrectly. An email was sent that shouldn't have been sent. Someone asks, what did the agent do? How did this happen? Who authorized it? And the answer comes back, we don't have that information. That answer is unacceptable. And yet, it's what most organizations have right now because they never wired auditability into their agent deployments. Auditability means three things. First, every decision is logged. When Lucy, the supervisor agent, decides to escalate something to a human, that decision gets recorded. What data did she evaluate? What rule triggered the escalation? What exact timestamp? Second, every tool call is captured. When Tim invokes the calendar API to schedule a meeting, the system logs the call, what parameters, what response, and what the agent did with the result. Third, every data access is tracked. Which agent accessed which file, when, what did it read, did it copy it, did it modify it, all of it logged. But here's the problem. Organizations assume that logging and auditability are the same thing. They're not. Logging is data, gigabytes of unstructured text saying what happened. Auditability is intelligence, the ability to answer specific questions about what happened, why it happened, and who was responsible. Purview Audit is the backbone here. It's Microsoft's unified audit log for Microsoft 365. Everything that happens in Exchange, SharePoint, Teams, OneDrive, and Graph flows into Purview. Agent activity gets captured there alongside human activity. Lucy reading a file, logged. Tim sending an email, logged. Olivia flagging a record, logged. One system, one source of truth. But here's the nuance. Agent logs and human logs are not the same thing. When a human accesses a file, it's because the human decided to access it. They searched, they found it, they opened it. That's one entry in the log. When an agent accesses a file, the context is different. The agent was instructed by its supervisor to check compliance on a candidate, and the supervisor was following a workflow that responded to a specific requisition. The access is part of a chain of decisions that extends backward. Auditability requires capturing that chain, not just the access event. This is where intelligent dashboards matter. Raw logs are noise. Thousands of events per hour, hundreds of thousands per day. You cannot read them manually. You need dashboards that show anomalies, that answer questions, and that flag patterns. A dashboard might show, this agent accessed files from 3 different departments in 1 hour. That's unusual. Why? A dashboard might show, this agent exported data at 2 a.m. That violates policy. Flag it. A dashboard might reconstruct a timeline. Requisition arrived Monday, sourcing happened Tuesday, compliance review happened Wednesday, but then compliance flags were overridden and hiring proceeded anyway. Who overrode them? Why? Integration with SIEM takes this further. Your SIEM, Security Information and Event Management System, is where security operations lives. It's where incidents get detected. Agent logs flowing into SIEM means your security team can see agent behavior in the same view as network traffic, user logins, and system changes. Anomalies that span agent activity and network activity become visible. An agent exporting data is suspicious, but an agent exporting data and uploading it to an external cloud storage service is an incident. SIEM sees both events and correlates them. A real example. An organization discovers that customer data was accessed inappropriately over a week. Someone asks, reconstruct what happened. The auditability system lets you walk backward through time. Day 1. Agent X accessed file Y because it was handling a support ticket. Day 2. Agent X accessed the same file again and then exported it, but no reason was logged. Red flag. Day 3. The file was shared externally by the export agent without authorization. The audit trail shows not just that it happened, but where governance broke down, where the escalation should have triggered but didn't, and where permissions should have blocked it but didn't. Observability tells you what happened, but you also need to prevent bad things from happening in the first place. Human approval loops, the safety gate. The foundation is built, identity is set, permissions are locked, audit trails are running. You have an agent that understands context and talks to other agents. But a massive problem remains. Some decisions need human judgment, and you cannot automate that away. The question isn't whether humans should stay involved. They have to be there. The real question is how you involve them without breaking the speed of the system. If every single action requires a person to stop and think, you have built a bottleneck. You have turned your agents into fancy suggestion engines. The human sees a recommendation, clicks approve, and moves on. You have only reduced the manual work by maybe 20%. The agent finds a candidate, but a person still screens them. The agent picks a meeting time, but a person still confirms it. This is not a transformation, it is just theater. The solution is the approval loop pattern. In this model, the agent proposes an action. The human reviews that proposal with the full context. The human makes the call. The system only executes if it gets the green light. The agent doesn't sit around waiting forever. And the human doesn't get buried in requests. The whole process moves fast enough to actually save time. But you must be clear about what needs a signature. Not everything does. An agent that can only act after a human reviews, it isn't really an agent, it is just a form generator. The line between doing the work and asking for help is where governance actually lives. Certain actions always need a human eye. Anything involving money belongs in this category. Payments, budget shifts, or changes to someone's pay. Anything that deletes information needs a check. Deleting records, closing accounts, or archiving data. Anything that goes outside the company needs a review. External emails, sharing with customers, or sending files to people without standard access. These actions carry risks that go beyond the moment. They have consequences down the line. Most routine tasks do not need this level of oversight. An agent reading an email doesn't need permission. An agent scheduling an internal sync doesn't need a sign-off. An agent updating a record within its normal range doesn't need a human. These actions are easy to undo. They fit inside the lines. The cost of making them wait for a person is higher than the risk of the action itself. This is where threshold-based approval changes the game. You don't approve specific actions, you approve ranges. An expense agent might auto-approve any claim under $150. It sends claims between $150 and $500 to a manager. Anything over $500 goes straight to finance. The agent isn't asking for permission every time. It is following a rule. Small claims are already within its authority. The user experience is the biggest hurdle here. An approval has to be fast, or it becomes a wall. If a person has to read a long story, dig for context, and open 3 different systems to check facts, that approval takes 10 minutes. Now the agent is stuck, the user is waiting. The time you were supposed to save is gone. The fix is the evidence pack. Instead of giving a human a raw request, the agent gathers everything they need to decide. An expense agent asking for an $800 registration doesn't just ask for the money. It explains that the employee used their training budget, but this conference is a requirement. It shows that previous years were approved and attaches the receipt. It even notes that the supervisor is on board. It takes 30 seconds to read. 1 click, done. The agent isn't just guessing. It provides the logic. The human sees exactly what data the agent looked at and which rules it applied. They see where the decision hit a boundary that required a person. The human can still override the system if they know something the agent doesn't. But usually the info is all there. The choice is obvious. The approval happens in seconds. In a real-world example, an HR agent handles expense reports. Small claims go through automatically. Medium claims go to managers with a summary and a receipt. The manager sees the amount and the recommendation. If it looks right, they click once. If it looks weird, they ask for more info. Large claims go to finance for a policy check. Finance sees that same evidence pack plus any compliance flags. The agent doesn't wait on people for the boring stuff. Humans aren't drowning in approvals they don't actually need to see. Approval loops work when the company has clear rules about human judgment, which leads us to how you manage this at scale. Agent 365, the control plane. Everything we have talked about, identity, permissions, audit trails, and approval loops, only works if you have a place to manage it. You need a way to see which agents exist. You need a way to set the rules. You need to know the second things go wrong. That is where Agent 365 comes in. Agent 365 launched on May 1st, 2026. It costs $15 per user every month. For the first time, companies have a single cockpit for agent governance right inside Microsoft 365. Think of it like this. Before Agent 365, managing agents was like trying to lock up a house when you didn't know how many doors it had. You might lock the front door. You might bolt the basement, but there could be windows you missed or back entrances you forgot about. You had agents running in dark corners of the network that nobody knew existed. You had logs and permissions, but you had no inventory. You couldn't see the whole system. Agent 365 fixes that by answering one simple question. What agents are actually running in your company? This is much harder than it sounds. You have agents built in Copilot Studio. You have others running in the Power Platform. You have local agents on developer laptops. You have tools from vendors and outside providers. You even have agents that IT doesn't know about because a team built them in secret. This is Shadow AI. These are the agents running outside the lines. The agent registry in Agent 365 is your source of truth. It shows you every agent. It lists the ones you built on purpose and the ones that showed up anyway. It pulls data from Entra, Defender, and Intune. It finds agents across 20 different types. You see coding agents, desktop apps, local tools, and remote servers in Azure. The registry gives you the full picture. Discovery is only the first step. You have to be able to act. That is why the risks column matters. Agent 365 looks at every agent and flags the problems. If an agent has permissions that are too broad, it gets a flag. If an agent is in production but was never approved, it gets a flag. If it touches sensitive data without logging, it gets a flag. If the behavior looks weird compared to last week, it gets a flag. Risk isn't just a yes or no. It is categorized as high, medium, or low. An agent with too much power is high risk. An agent that nobody uses is low risk, but you should still check on it. An agent with no owner is a major red flag. If a production agent has been fined for 6 months but suddenly changes its permissions, it moves to medium risk. These risks make governance something you can actually do. A company doesn't have the time to manually check thousands of agents, but they can focus on the ones with flags. They can ask why an agent has write access to the whole SharePoint tenant. They can ask why an agent is suddenly touching data it has never seen before. Policy templates bring all these controls together. Agent 365 has baseline and enhanced options. Baseline is for low-risk agents. These are the ones that just read info and make suggestions. The baseline template sets up standard policies and basic logging. Enhanced is for the high-risk stuff. These are agents that change records, send messages, or touch core business systems. Enhanced adds real-time monitoring and forces human approvals. You don't have to build your governance from scratch. You just pick a template. It puts the right guards in place. As you learn what works, you can tweak the templates. You change the thresholds. You add new rules. The templates grow as your company gets better at managing AI. Agent 365 is basically mandatory if you are running more than a few agents. The alternative is just chaos. You end up with agents scattered everywhere with no central view and no consistent rules. Every team ends up making their own approval process, or they don't make one at all. Every agent has its own way of logging, or it doesn't log anything. You aren't governing agents at that point. You are just jumping from one crisis to the next. The sign that a company is actually ready for AI is the move from we have agents to we govern agents. The early stage is simple. You build an agent, it works, and everyone is happy. The mature stage is different. You have an inventory, you rank them by risk, you apply policies across the board. You know the moment something changes, and you have a plan for when it does. Agent 365 is the piece of the puzzle that makes that mature state possible. Agent 365 is the control plane, but governance isn't just about the tech. It is about the organization. The governance framework, ownership and accountability. Here is what kills agent deployments. Nobody owns them. You build an agent, it works, and you deploy it. It starts handling real work. But 3 months later, nobody remembers who actually built the thing. Nobody knows who is responsible if something goes wrong. The agent keeps running because nobody has the permission to turn it off. Requirements change, but the agent is still applying old rules from last year. A security vulnerability is discovered and nobody patches it because the person who understands the code left the company 6 months ago. That is a governance failure. It is not because of a bad policy. It is because nobody has accountability. Ownership starts with a person, not a team label, not a department, a named individual, someone whose job description includes maintaining this specific agent, someone who can be contacted when decisions need to be made, someone who gets woken up at 3 in the morning if the agent starts behaving wrong. That ownership forces clarity. It forces accountability. It forces someone to actually care about whether the agent is running correctly. The RACI model translates that ownership into roles. Who approves new agents? Who reviews them before they go live? Who operates them day to day? Who escalates when something breaks? These are not the same people, and that is the point. An engineer builds the agent. They are responsible for the implementation. They understand the code, the logic, and the tool integrations, but they do not get to approve it for production. Approval comes from a business owner. This is someone who understands what the agent is supposed to accomplish and whether it actually does that. The business owner is the one who approves it for production deployment. Once it is live, operations owns it. Operations monitors the agent. They run the checks. They get alerted if something goes wrong. But operations does not make business decisions about what the agent should do. That is the business owner's job. And if there is a fundamental problem where the agent is causing harm or violating policy, operations escalates. The escalation goes to a governance committee or a security team, someone who can make the decision to shut the agent down if necessary. This separation of concerns is why RACI works. It distributes accountability so that no single failure point tanks the whole system. The engineer cannot quietly deploy a broken agent because the business owner has to sign off. The business owner cannot prioritize speed over safety because operations and governance have veto power. Operations cannot make business decisions unilaterally because they are not closest to the business problem. Risk classification determines how strict the process is. A low-risk productivity agent might just read documents and summarize them. That has a lightweight approval process. The business owner signs off, operations sets it up, and it is done. But a high-risk agent is different. If it modifies financial records or makes hiring decisions, it goes through a full approval workflow. Business review, security review, compliance review, governance sign-off. It takes longer. That is intentional. The risk is higher. The approval workflow is the path from development to production. A developer has an idea for an agent. They submit it to a governance board. The board evaluates the business case. Is this actually needed? Does it solve a real problem? They evaluate the risk. What could go wrong? What would the impact be? They evaluate the technical design. Does it follow our architecture standards? Are the permissions appropriate? If all 3 checks pass, it moves to a pilot phase. Limited deployment, real data, real users, monitoring to see if it actually works as intended. Only after the pilot succeeds does it move to full production. And production deployment comes with conditions. This agent runs in this team only. This agent uses this data only. This agent escalates to a human if the confidence falls below a certain threshold. These are not afterthoughts. They are built in from the approval. Lifecycle management means the agent has a lifespan. It is created, it is deployed, it is monitored. At some point, either it evolves into something new or it is retired. You do not run agents forever without review. You have a quarterly governance review where agents are evaluated. Are they still serving their original purpose? Have requirements changed? Is the agent still secure? Is the risk profile still appropriate? The review is not optional. It is built into the process. KPMG manages 276,000 agents across 138 countries using this exact framework. Not because KPMG likes process, because at that scale, process is the only thing that keeps chaos from consuming the whole system. Every agent has an owner. Every agent has risk classification. Every agent went through approval. Every agent is reviewed quarterly. That structure is how they scale. Data protection for agents, DLP and sensitivity labels. Agents leak data the way humans do. Sometimes by accident, sometimes by design, sometimes because they are tricked. A human gets a phishing email asking them to forward customer data. Usually they realize it is suspicious and refuse. An agent does not evaluate intent the same way. Give an agent access to customer data and an instruction to send this to the integration partner, and it sends it. If the instruction came from a prompt injection attack buried in a document the agent was analyzing, the agent has no way to know. It followed a logical instruction from what looked like an authorized source. This is not a theoretical risk. This is how breaches happen. An agent reads data it is allowed to read. A prompt injection attack modifies that data before the agent processes it. The attack tells the agent to exfiltrate information. The agent, reasoning logically from the modified instructions, complies. The data is gone. Data loss prevention for agents is the first line of defense. Purview DLP does not just apply to humans anymore. It now has specific agent enforcement modes. When an agent tries to process sensitive data, DLP can intercept the flow before the data reaches the model. This is the critical moment. If DLP blocks the sensitive data here, the model never sees it. The agent cannot accidentally leak what it never had access to. The way this works is that DLP policies get evaluated on agent prompts. You mark certain data as confidential, like customer records, financial information, or trade secrets. You define a DLP rule. If an agent tries to process confidential data, block it. When an agent reads a customer email marked as confidential and tries to summarize it, DLP intercepts the operation. The email is not included in the prompt, the agent processes a redacted version or does not process it at all. Every blocked attempt gets logged in Purview for forensic investigation. But DLP is reactive. It blocks bad things. Sensitivity labels are proactive. They mark data at the source and control how agents can use it. A sensitivity label answers one question. What is this data and what can happen to it? You mark an email thread as customer confidential. Agents can read it for specific business purposes. Agents cannot export it. Agents cannot use it for model training. Agents cannot share it with external systems. The label travels with the data. If the email is forwarded, the label stays. If the content is quoted in a report, the label applies to the report. But here is the subtle distinction that matters. It is the difference between the agent can read this and the agent should read this. Permissions determine what an agent can technically access. A sourcing agent has read access to candidate files. That is permission. But should a sourcing agent read the detailed performance reviews of candidates, technically the performance reviews might not be restricted. The agent has read access to the HR system. But organizationally, a sourcing agent should not read that data. It is not relevant to their job. Reading it creates exposure. Sensitivity labels enforce that should. They are not permission boundaries. They are organizational policy. A label says this data is performance data, and agents should not process it without executive approval. When a sourcing agent queries the system, performance data gets filtered out, not because the agent lacks permission, because the label prevents inappropriate use. This matters because compliance lives in the should layer, not the can layer. An audit asking why an agent accessed sensitive data does not accept it had permission as an answer. Regulators want to know why. Sensitivity labels force that conversation up front. They prevent inappropriate access before it happens. Retention and deletion becomes an agent problem because agents build context. They read documents. They build memory from that reading. If that document needs to be deleted for compliance, for a user request, or for data minimization, the agent needs to forget it. This is not how AI systems usually work. Models do not forget, but governance requires it. Consider an agent that supports customers by reading their email history. The agent can read customer emails to provide better support, but it cannot export those emails or use them to train other models. The emails are marked with retention and usage labels. When the retention period expires, the agent purges that conversation history. When the customer requests deletion, the agent purges immediately. The governance model is built into the agent's data handling. This is why data protection is not optional when agents handle regulated data. It is the guardrail that prevents the system from becoming a liability. Real-world deployment patterns, HR agents. HR is where multi-agent orchestration proves its value in production. It works here because HR workflows force you to get governance right. They have 3 specific traits. First, they are high volume, every new hire, every onboarding, every benefits question. These tasks repeat constantly. Second, they are rule-based. You have regulations and company policies that cannot be bent. Third, they span multiple systems. You have the ATS, the HRIS, payroll, benefits platforms, and email. No single system owns the full workflow. If an agent can only read one system, it is useless. This combination means HR cannot tolerate sloppy orchestration. You can build an experimental agent that summarizes emails and it might work fine, even if it misses some nuance. But HR agents have downstream consequences. A hiring agent that misclassifies a candidate costs the company time. An onboarding agent that forgets to provision an account kills productivity. A support agent that gives the wrong benefits advice creates legal exposure. The hiring workflow starts with sourcing. A sourcing agent queries the ATS, LinkedIn, and internal referral platforms. It returns candidates ranked by match quality. This ranking is deterministic. It follows explicit criteria like skills, experience, and location. The agent evaluates candidates against those specific requirements. It does not add subjective judgment. It does not prefer a candidate just because their background looks interesting. It simply evaluates against the rubric. From there, the workflow moves to screening. A screening agent evaluates the candidates the sourcing agent found, but screening is more complex than sourcing. This is where subjective judgment enters the process. Does this person's background actually fit? Beyond just a keyword match, are there red flags in their history? Do they meet the culture fit criteria? A screening agent is not just an algorithm. It is reasoning. It reads resumes, understands context, and makes judgments. Then comes scheduling. An interview scheduling agent coordinates availability across the candidate, the interviewers, and the facilities. It checks calendars. It proposes time slots. It sends invitations. It even handles rescheduling when conflicts arise. Scheduling is purely transactional, but it is incredibly time-consuming when done manually. An agent that handles this saves hours per hire. Offer generation follows. Once the interviews are over and the hiring decision is made, an offer agent generates the letter. It pulls from templates and inserts candidate data like salary, start date, and reporting structure. It incorporates regulatory language. It adds company-specific terms. The offer then gets routed for approval before it is sent out. Background checks run in parallel. Some organizations run them before the offer, while others run them after. Either way, an agent tracks the process. It submits the request. It tracks the status. It flags issues. It integrates those results back into the hiring decision. Each of these steps requires different expertise. Sourcing requires understanding qualifications. Screening requires judgment about culture. Scheduling requires coordination. Offer generation requires legal accuracy. A single agent trying to handle all of this gets overwhelmed. It lacks clear domain boundaries. Its decisions become confused because it is switching contexts constantly. The error rate climbs, and the latency explodes. The multi-agent approach assigns each step to a specialist. A sourcing agent owns sourcing. A screening agent owns screening. An interview scheduling agent owns scheduling. Each one is an expert in its domain. Each one has a narrow scope. Each one makes clean decisions within clear boundaries. The supervisor coordinates them, the hiring manager submits a requisition, and the supervisor sees that as a new workflow. It invokes the sourcing agent. Sourcing completes. The supervisor invokes screening. Screening flags 2 top candidates. The supervisor invokes scheduling for both. Parallel interviews happen. Results come back. The supervisor evaluates them. The hiring manager chooses. The supervisor invokes offer generation. The offer gets approved. The supervisor invokes background checks. The results come back clean. And the workflow completes. The person is hired. The metrics that matter here are measurable. Time to hire drops because agents eliminate manual handoffs. Onboarding cycle time shrinks when the same pattern handles document collection, IT provisioning, and benefits enrollment. Employee satisfaction rises because the process is consistent. Nobody's hiring experience depends on which HR person happens to be available that day. Imperium Labs reduced their manual HR workload by 50% using exactly this orchestration pattern. They did not do it by replacing humans. They did it by eliminating the friction that made humans inefficient. HR is one use case. Let's look at another. Real-world deployment patterns. IT operations agents. IT operations is different from HR in a fundamental way. If an HR agent makes a mistake, someone doesn't get hired, or they get onboarded slowly, that is bad. But if an IT operations agent makes a mistake, systems go down, infrastructure fails, customers lose access, the organization hemorrhages money by the minute. This is why IT operations is the highest stakes orchestration use case. The consequences are not delayed, they are immediate and measurable. The ticket triage workflow is where most IT operations agents start. Support tickets arrive constantly, users report problems, equipment breaks, software crashes. A human has to read each ticket, understand what is being reported, and route it to the right team. This is work that happens at volume. A medium-sized organization gets hundreds of tickets every day. A triage agent reads incoming tickets. It extracts the essential information. What system is affected? What is the symptom? Who is impacted? It classifies the ticket as a network issue, a software issue, or an access issue. Based on that classification, it routes the ticket. A network issue goes to the network team. An access issue goes to identity. But triage is not binary. Some tickets have overlapping concerns. An employee might not be able to access an application because their VPN connection is failing. That is both a network issue and an access issue. The triage agent recognizes the overlap. It routes to both teams and flags that they need to coordinate. Initial troubleshooting happens in parallel. While the ticket is being routed, a troubleshooting agent starts investigating. It checks the system status. Is the service actually down, or is the user having a local problem? It checks the user's configuration. Are they using the right VPN settings? Did they restart their machine? The troubleshooting agent gathers data. If it can resolve the issue, like restarting a service or resetting a password, it closes the ticket. If it cannot resolve it, it escalates. The ticket goes to a specialist with context. The agent says, "Here's what I tried. Here is what I found. And here is where you need to start." Escalation is the clean handoff. The triage agent did not waste the specialist's time. The specialist does not start from zero. They start from context. That efficiency compounds across thousands of tickets. Change management is the second workflow. An IT team member wants to update a server or patch software. The change cannot just happen. It needs approval, it needs planning, it needs coordination so that it does not break something else. A change management agent handles this. Someone submits a change request, and the agent evaluates it. Is this change within policy? What systems does it touch? The agent checks the change against the dependency graph. If a change touches a system that supports critical business functions, it gets routed for risk review. If it is routine maintenance with low risk, it gets approved faster. Either way, the agent schedules it. It coordinates the timing so that multiple changes do not stack. It triggers notifications so the right teams are ready. It monitors execution. It validates that the change worked as intended. Incident response is the third workflow. An alert fires. A system is down. The organization is bleeding money right now. An incident response agent does not wait for a human to notice. It detects the alert. It launches the response immediately. It gathers data. What is the scope of the impact? Which systems are affected? Are customers impacted? It triggers notifications to the incident commander. It opens a communication channel in Slack or Teams. It begins remediation. Does it have authority to restart a service? Can it fail over to a backup? Can it isolate a compromised system? For anything it cannot do. It guides the incident commander. It provides the data and the recommendations. The communication happens in real time, with the agent updating context as the situation evolves. But here is where IT operations becomes genuinely complex. Nothing exists in isolation. A change to one system affects others. A network failure impacts applications that depend on that network. The agents need to understand IT dependencies, not as a list, as a graph. The network knowledge graph represents the infrastructure topology. Systems are nodes, dependencies are edges. When a system fails, the agent does not just flag that the system is down. It knows what depends on it. It knows what the blast radius is. It knows which users are affected. It can predict cascading failures if the primary database server is down. It knows which applications are impacted. It knows how quickly they will fail over, and what the recovery time objective is. An organization that combined multi-agent reasoning with a dynamic network knowledge graph improved ticket resolution speed by 40%. This did not happen because individual agents got faster. It happened because agents stopped investigating blind. They could see the full picture. They understood dependencies. They routed tickets to the right team immediately. This pattern generalizes. Any domain with complex interconnected systems benefits from the same approach. IT operations is complex, but there's a pattern here that applies to other domains too. Real-world deployment patterns, sales and customer success agents. Sales is the highest value use case for agents because the economics are fundamentally different. In HR, agents save time. In IT operations, agents prevent downtime. But in sales, agents directly impact revenue. An agent that helps a rep close one extra deal a quarter pays for itself, but an agent that helps a rep close 5 deals becomes a strategic asset. The lead qualification workflow starts the moment a prospect enters the funnel. An agent researches them immediately. What company are they at? What is their industry? What is their role? What problems are they likely facing? The agent pulls from multiple sources: CRM history, LinkedIn, company news, industry reports, product usage data. It synthesizes this into a profile. It is not a guess, but a data-backed assessment of who this person is and why they might be interested. Then comes scoring. The agent evaluates the lead against your ideal customer profile. How closely do they match? What is their urgency? What is their buying power? The scoring is not a number. It is a ranking with reasoning. This lead matches because they are in healthcare, they have a large IT budget, and their company is growing. That lead ranks lower because they are in education, which has different buying patterns. The ranking helps the rep prioritize. Instead of working leads randomly, they work the most likely to close first. Prioritization and outreach follow. The agent does not just rank leads. It times the outreach. Is this the right moment to reach out? Did something change in the prospect's world that creates urgency? Did a competitor win a deal? Did they announce funding? The agent finds the trigger events. It sequences the outreach. First an email with relevant insight, then a follow-up with a use case study, then a calendar invite to a demo. The sequence is proven. The timing is optimized. The rep does not have to guess. Opportunity management is the next layer. A prospect becomes a deal, and now the agent tracks that deal through the sales process. What stage is it in? How long has it been there? What is the probability of close? The agent does not just report status, it recommends next best actions. The deal is stuck in evaluation, so the next step is to schedule a technical validation. The agent sees when the customer is available, and it knows which internal expert to involve. It surfaces recommendations that move deals forward. Proposal generation happens in parallel. Once evaluation is underway, a proposal agent drafts the document. It is not a templated form letter. It incorporates everything learned about the customer, their specific challenges, their stated priorities, their team structure. The proposal reads like it was written specifically for them because it was. The agent incorporated research and context at every step. The rep reviews, maybe tweaks a few sentences, and sends it. Deal tracking happens throughout. The agent monitors signals that the deal is progressing or stalling. Meeting scheduled, deal momentum increases, decision pushed, momentum decreases. Key stakeholder leaves the company, red flag. The agent alerts the rep to changes immediately. Customer success operates on similar principles. An agent monitors adoption. Is the customer using the product they bought? Are they using it the way they should? An agent detects churn signals, usage dropping, feature adoption stalling, support tickets increasing. These are early warning signs. The agent alerts the success team before the customer leaves. Renewal management uses the same multi-agent pattern. An agent tracks contract renewal dates. It monitors customer health. It identifies expansion opportunities. A customer bought 3 licenses, but usage data shows they need 5. The agent recommends expansion. It prepares the business case. It schedules the renewal conversation at the optimal time. ServiceNow built exactly this system. Multiple agents coordinating across CRM, communication history, and product usage data. The metrics they track are directly tied to revenue, pipeline velocity, deal size, customer retention. This pattern is expanding because every function is discovering the same truth. Complex workflows benefit from coordinated specialist agents. Measuring agent success, the scorecard. Here is what separates organizations that scale agents from organizations that get stuck. They measure the wrong things. The instinct is to measure accuracy. Did the agent get the right answer? For a system that generates text, accuracy feels like the natural metric, but agents do not generate text. They accomplish tasks. They are not writing essays. They are qualifying leads, scheduling meetings, resolving support tickets, and managing hiring workflows. The right metric for those tasks is not how correct the output was, but whether the task completed successfully. Accuracy is almost irrelevant. A sourcing agent could perfectly describe why a candidate matches your job requirements. Perfect accuracy. But if the candidate turns out to be a bad fit for your team, the agent failed. You need a different metric. Did the qualified candidate actually succeed in the role? That is success. That is what matters to the business. This is why the multi-level scorecard exists. You need measurements at 3 levels, and they are not interchangeable. Agent-level metrics tell you if an individual agent is doing its job. A sourcing agent's task success rate is the percentage of candidates who make it to the interview stage. A scheduling agent's task success rate is the percentage of meetings that actually happen without rescheduling. These are narrow metrics. They measure one agent's specific function, but they are the first place to look when something breaks. Workflow level metrics tell you if the coordinated system is working. The hiring workflows metrics are different from individual agent metrics. Time to hire matters. How long from requisition to offer? Offer acceptance rate matters. Of candidates who receive offers, what percentage accept? Quality metrics matter. Of hired candidates, what percentage are still in the role after 1 year? These are the metrics that tell you if the multi-agent orchestration is actually improving hiring outcomes. Business level KPIs tell you if the agents are moving the needle on what actually matters. Revenue impact, cost savings, customer satisfaction, market speed. These are the metrics that executives care about. If you deploy agents and your hiring metrics look great, but you are not improving time to market or product quality, then the agents are cosmetic. Business metrics are what justify continued investment. The practical scorecard for a hiring workflow looks like this. Agent level, sourcing agents' candidate quality score, screening agents' accuracy, scheduling agents' on-time performance, workflow level, time to hire, offer acceptance rate, new hire retention. Business level, organizational hiring velocity, product launch speed, revenue growth. When you are evaluating whether agents are working, you read them all together. If agent-level metrics look good but workflow metrics are stagnant, the problem is orchestration. The agents work individually but do not coordinate. If workflow metrics look good but business metrics do not move, the problem is scope. You are automating the wrong process. It is not slowing down anything that matters. You need to measure both efficiency and safety. This is where organizations make a critical mistake. They optimize purely for speed. Agents that complete tasks fast, agents that escalate rarely, agents that move workflows forward. But if those fast agents are hallucinating, violating policy, or taking shortcuts that create downstream problems, then you have not optimized anything. You have just shifted the cost somewhere else. A sourcing agent that qualifies quickly but misses red flags creates bad hires. That is not saving time. That is creating cost later. The metrics that matter: task success rate. Did the agent complete the task correctly? Containment rate. What percentage of issues resolved without escalation? Cost per interaction. How much did this workflow cost to complete? Hallucination rate. How often did the agent make up information? Policy adherence rate. Did the agent follow rules? Escalation frequency. How often did it hand off to humans? Real example. An organization tracking all these metrics found that their support agents had high containment. They resolved issues without escalation, but their hallucination rate was 12%. They were confidently giving wrong answers. They were escalating the right issues, but they were confidently misresolving others. Once they saw that metric, they understood the problem. They were not measuring whether the issue was actually solved. They were measuring whether the agent answered instead of escalating. Once they fixed the measurement, they fixed the real problem. The metrics themselves become the governor. They force you to measure what actually matters. Metrics tell you if something is working, but they also tell you what to fix. The governance crisis: why 74% of deployments lack mature controls. The numbers tell a story that should terrify any architect responsible for enterprise infrastructure. 74% of organizations are running AI agents in production, but only 21% have governance that actually works. That gap is not a coincidence. It's the inevitable result of moving faster than your organizational structures can handle. Because in reality, most companies are building without breaks. You build an agent. It works. It solves a problem. You deploy it, and then other teams see it working and want agents too. You build more and you deploy more, but nobody is stopping to ask if the infrastructure is actually ready. Nobody is checking if the policies you wrote last month still apply to the agents you're shipping this month. The adoption governance gap is the defining challenge of 2026. Agents are everywhere. Governance is nowhere. And in that gap, problems multiply. The no users can access agent policy flaw is a perfect case study of what happens when governance lags behind. An organization tried to be cautious and set a policy where no regular users could access agents. They wanted only approved people in approved roles to have access, so the policy was written and the setting was configured. But the setting didn't actually block the agents. There was a gap between what the policy intended and what the system actually enforced. Some agents still showed up in user catalogs, and others could still be invoked by people who shouldn't have seen them. The control failed because nobody validated that the policy did what it was supposed to do. That's where things change, and usually for the worse. When the policy didn't work, someone started doing manual PowerShell overrides in the middle of the night. They manually disabled agents one by one with scripts that weren't documented or explained to the rest of the team. That approach doesn't scale, it isn't auditable, and it definitely isn't repeatable. But in the absence of real governance, it's what organizations fall back on. Then you have the shadow AI problem. This is the dark side of the governance gap, where agents are running in your infrastructure that your team doesn't even know about. A developer builds an agent locally, containerizes it, and runs it in Azure without telling a soul. It's pulling from SharePoint, querying your databases, and sending emails while nobody has classified its risk or set up monitoring. It stays invisible until something goes wrong, and then there is the permission explosion. This happens because there's no systematic way to enforce least privilege when you're moving this fast. You give an agent access to the systems it needs today, but you also give it access to things it might need next year. You give it broader access than necessary because being too restrictive slows down the deployment schedule. Over time, agents accumulate permissions like digital debt. Each new agent starts with broad access because nobody has time to calculate exactly what's necessary. The system becomes progressively over-permissioned. The audit blind spot is where governance completely breaks down. An agent executes an action and something goes wrong, so someone asks what the agent actually did. The logs might show a file was accessed or a record was modified, but the logs don't show why. They don't show what data the agent evaluated or what reasoning led to that specific decision. They don't show which human approved it or if approval was even required. The organization has activity logs, but they don't have intelligence. This matters because 97% of AI breaches stem from insufficient access controls. It's not about sophisticated attacks or compromised models. It's about agents that had access they shouldn't have had. It's about agents taking actions without oversight and leaking data because the boundaries were never defined. The governance crisis is what enables the security crisis. The path forward is straightforward in principle but difficult in execution. You have to move from ad hoc controls to programmatic governance. Stop relying on manual processes and stop assuming policies work when you haven't actually tested them. Stop letting agents run invisibly. You need to build the infrastructure that allows governance at scale. That's what Agent 365 and the governance framework are designed to provide. But they only work if you actually use them. Building the governance program. Practical steps. The transition from crisis to control happens in phases. You can't fix everything at once. If you try to lock down every agent and every process overnight, you'll just paralyze the organization. You'll make agents look like they slow things down instead of speeding them up. The winning approach is methodical, but fast. Step 1 is inventory. You need to know what agents actually exist in your environment. Use Agent 365 to scan your infrastructure and run discovery across Entra, Defender, and Intune. Document everything from the agents you built on purpose to the shadow agents running in dark corners. Create a spreadsheet with the agent name, the owner, the purpose, and exactly what data it touches. This inventory is your starting point. You can't govern what you can't see. Step 2 is classification. Not all agents are equally risky, so you have to treat them differently. A productivity agent that just reads and summarizes documents is low risk. A payment agent that moves actual money is high risk. A hiring agent that evaluates candidates sits somewhere in the middle. Classify every agent on your list as low, medium, or high. This classification determines how strictly you govern it and whether it needs human approval loops. A low-risk agent can move through the system faster, but a high-risk agent needs a full review. Step 3 is ownership. Go through that inventory and assign an actual person to every single agent. Not a team or a department, but a named individual who is accountable. That person is responsible for making sure the agent operates correctly and responding if there's a security issue. Ownership forces accountability. And it forces a hard truth. If nobody is willing to own an agent, it probably shouldn't exist. Step 4 is approval workflows. You need to define the path from development to production. For a low-risk agent, maybe the business owner signs off and engineering validates it. For a high-risk agent, you need business, security, compliance, and operations all to sign off. Define the criteria and decide who has veto power. The workflow is the guardrail that prevents bad agents from reaching production. Step 5 is identity and access controls. Every agent gets a dedicated Entra workload identity. No sharing human accounts and no standing API keys. The agent's identity should have specific roles and only the permissions it needs to function. Configure conditional access and extend the same policies that protect human accounts to your agents. If an agent's behavior becomes strange, the system should flag it the same way it would for a human. Step 6 is audit logging and monitoring. Turn on Purview Audit and capture every tool call and every data access, but don't just collect logs, make them intelligent. Build dashboards that show anomalies and flag patterns that look suspicious. An agent accessing files from 3 different departments in 1 hour is unusual. An agent exporting large volumes of data is a red flag. The logs are only useful if you can actually reason over them. Step 7 is escalation. Define what happens when something goes wrong. When an agent violates a policy or its behavior changes unexpectedly, who gets the notification? Who has the power to shut the agent down immediately? Escalation procedures prevent small problems from becoming full-blown security incidents. Phased rollout matters because you need to prove the model works before you scale it. Start with low-risk agents where the blast radius is small and failure is easy to recover from. Run them through your governance process and see if your oversight structure actually catches real problems. Only after you've proven the model on low-risk deployments should you expand to high-risk ones. KPMG governs 276,000 agents using exactly this framework. They didn't deploy governance as an afterthought. They built the framework first, proved it worked, and then expanded systematically. That's how you operate at scale without the chaos. The future, where this is heading. We are at an inflection point. The shift happening right now is not about moving from chatbots to better chatbots. It is a shift from agents as tools to agents as workers. A tool is something you invoke when you need it. You open it, you tell it what to do, and you close it when you are done. But an agent as a worker is different. It operates within boundaries you set. It monitors, it detects, it acts. You check on it periodically, you set new objectives when needed, but it is not waiting for you to pull a lever every time something needs doing. This shift forces everything to scale differently. You cannot govern 5,000 tools the way you govern 10, but you can govern 5,000 autonomous workers if you have the right infrastructure. That infrastructure is what we have been building through these sections. Graph as the data layer, MCP as the integration standard, LangGraph as the orchestration framework, Agent 365 as the governance cockpit, Entra and Purview as the identity and compliance backbone. Graph will remain the central nervous system because it is the only system that actually knows your organization. It contains 2 decades of communication patterns, relationships, and decisions. It knows how work actually flows. When AI agents operate at scale, they are not operating in a vacuum. They are operating inside the live organism of your organization. They need real-time access to that context. Graph provides it. The convergence of MCP, LangGraph, and Agent 365 is creating the operating system for agentic workflows. MCP standardizes how agents talk to external systems. One protocol, many tools. LangGraph provides the orchestration framework that lets agents coordinate with each other. Supervisor patterns, multi-step workflows, stateful interactions. Agent 365 ties it together with governance, central identity, central policy, central audit. What agentic workflows actually means is orchestrated, auditable, governed automation, not loose agents doing their own thing, but coordinated agents operating within clear boundaries, leaving trails, escalating when necessary, fitting into the broader organizational system. An agentic workflow is not an experiment. It is core infrastructure. It is how the organization operates. But there is a skill gap that most organizations have not reckoned with yet. Building graph-powered agents requires you to understand both AI and enterprise systems. You need architects who know LangGraph and orchestration patterns, but also understand Active Directory Exchange and SharePoint governance. You need engineers who can write prompt instructions, but also understand data classification and retention policies. You need security teams that understand both LLM risks and traditional enterprise security. Those people are rare. Organizations are going to fight over them. Why this matters to your organization is simple. Agents are not a technology choice anymore. They are a structural choice. You are deciding whether your organization operates with manual processes where humans are the bottleneck, or whether you operate with autonomous workers handling routine decisions. That is not a tool decision. It is an architectural decision. It affects how you organize teams, how you measure performance, how you allocate resources. The decision point is whether you are building isolated agents or building an agentic enterprise. Isolated agents are experiments. You build one. It works. You add another. They do not coordinate. They duplicate effort. Each one is a custom integration problem. An agentic enterprise is different. Agents are coordinated. They operate within a unified governance framework. They use standard protocols. They share infrastructure. What to do next is not complicated, but it requires commitment. Start with one high-value workflow: HR hiring, IT ticket triage, sales lead qualification. Pick something where you can measure impact immediately. Build the agents, measure the outcomes. Did time decrease? Did quality improve? Did costs go down? Once you have proven the pattern on one workflow, expand systematically. 2 workflows, then 4, then 8. Each expansion gets faster because you are not rebuilding the governance infrastructure each time. You are using the framework you already built. The core insight that ties everything together is this: graph-powered agents are not about AI. They are about enterprise architecture. The difference between agents that transform your organization and agents that become expensive experiments is whether they are built on solid structural foundations. Graph provides data, MCP provides integration, LangGraph provides orchestration, Agent 365 provides governance. Together, they are the stack that lets agents operate at scale. Moving beyond chat matters because agents that can only talk are not agents. They are chatbots with good conversational skills. Real agents understand context. They act with authority. They operate within governance boundaries. They change how work happens, not how people talk about work. If you are responsible for enterprise architecture, you need to understand this now. Not next year. Not when vendors tell you it is ready. Now. The organizations that move first will embed agents into their operations before governance becomes the constraint. The organizations that wait will spend 2 years trying to retrofit governance into systems that were not built for it. Start with one workflow. Measure success. Expand. That is the path forward.